Hi there, I'm Scott Alberts. I'm a statistics professor here at Truman State University, and I'm just making a short video to walk through some of the data that we're seeing regarding COVID-19. And this video is a preface to that video that explains kind of how we think about this sort of data as we do things. So let me go here to a quick link so that I can talk to you about it. Okay, so there we go. All right, so let me start here with just going to a Wikipedia page. And this page is about exponential growth. And let me zoom in here in this picture here. Now, in your high school math classes, you probably remember learning about lines, and that's what the red thing is here. And of course, lines are nice and easy, and they make a lot of sense, and they go straight. And lots of things that we study follow patterns that are lines. The other one that you probably learned a lot about in Algebra 2 or pre-calculus or whatever class you had looks at these blue lines, which are polynomial curves, right? So the idea that you have an x cubed or an x squared or whatever, and sometimes you smush them together to make fancier curves. But what you can see is that the blue line starts a little bit lower and then starts zooming up. And we know that's what polynomial functions do, is that they grow much faster than a linear one. What you probably didn't, excuse me, what you probably didn't spend as much time in school learning about were exponential curves. And even those of us who've had calculus tend not to think about it quite as much as we do for polynomials. So anyway, exponential curves zoom up even faster. And you can see how the exponent is switched around here. So instead of x to the third, we have 2 to the x. Often we use e to the x because that has some nice properties that we see. And the fact that the COVID-19 spread looks exponential is what really has statisticians and public health people kind of freaked out, because exponential growth gets huge really quick and starts from almost nothing until it doesn't. And so worrying about exponentials is something that public health people really worry about. Now, of course, in practice, an exponential can't go on forever, right? Because it would go to infinity or whatever. And we know that it's eventually going to level off, even if in a dark way. Once everyone has the disease, it's going to level off at 7 or 8 billion people or whatever. So instead, we use a function called logistic. And in school, you didn't learn much about logistic at all, because the formula for it is a little bit more complicated. You can see the e is in there and then this exponential on the bottom of the fraction. The L on the top of the fraction is just the maximum value of it. So anyway, if we zoom in on the curve, you can see that it follows an exponential shape, but then it levels off. So logistic curves are what we actually in practice worry about, but when we see exponentials, we worry about that. There's also the case of things that have a normal or Gaussian shape, where they start up here and then they go back down. And that's where you get the bell curve that those of us in stats like to talk about so much. So the question is, when will this exponential curve start to level off? Now, seeing where that happens on an exponential curve is actually pretty tricky. So what we often do is we do what we call a log transform. And what a log transform does is it turns a perfect exponential into a perfect line. Now, we need to do that not because of some mathematical reason, theory reason, but because it makes it a lot easier to see, right? People are really good at looking at lines and telling if something is a line or not. Whereas if something is an exponential turning into a logistic, it's really hard to see that right here is where it switches from being kind of an uppy exponential curve to one that's leveling off. So that's why we do these log transforms. So I'm making this video in 2 parts because the data itself is changing so quickly. I want to be able to keep using this first video for a while, even as I update the second video, which actually looks at the real data. So that second video will come up here shortly.